enterprises or career related to the data. And today I'm going to talk just a little bit more about the big data, because all products, all studies, such as artificial intelligence, machine learning, data science, all lies on the, all have one main component, it's data. So we will talk about the data today, and also about the, what kind of studies we have, how we use big data in at Beeline, and also we will talk about the Geoanalytics and how important is data visualization role, since a lot of people saying about the statistics, mathematics, programming, and so on, but no one is speaking actually how to present data, and data literacy from this side is just a little bit is lacking. So first part is just I want to present just a little bit about our team, big data at Beeline Uzbekistan. As you can see, it's like also different studies which can be interesting for you, because I guess you're thinking when I go like right away, I want to be data scientist, machine learning, or like I want to be data analyst. For better understanding, I will try to explain in the example of Beeline. So we have head of big data, he's also here. He's our big boss who also giving us directions, data strategies, what to do, building and managing our operations, pipelines in support of data analytics use cases, leading our team for sure. And we have also several products which will be also presented here, or it will be also presented in a stance, so you can also see them. We have medical phrase, it's our managers and product owners. In Beeline, we have several products, and they all leading by product owners. They are presenting their products, and they try to present it to the businesses, to our stakeholders, and they're fighting for their products with their own teams. So we have data engineer, he's also here, he's our superhero, because everything lies on the efforts of, like in his efforts, and we really appreciate his contributions into our team, because with a data engineer, none of us can work, because data scientists or data analyst is also need a well-built data system, well-organized data system, and we also should understand that we also should get the access to the data actually, and also we should test the data through this pipeline. So I think that data engineers are current heroes, and actually, you know, everyone's saying that data scientists are like unicorns. They not exist. It's not true. We cannot find a second data engineer in our company. So I think unicorns are superheroes and more data engineer. And if you want to become specialist, will be highly demanded in the market, you should also learn data engineering fundamentals, and it will be really, I guess, helpful for your future careers. Data scientist is someone who is collecting data. He's someone in between data analyst and data engineer who is collecting data. He should also understand the technical part, but from other side, he also should understand business strategy and business part of the data. He also should know how to teach the models, create the new models, and we have, like, if we have 5 data analysts, 4 data scientists, I guess. So there exists actually. They're not unicorns generally, and they also analyzing data, building new models which help us make money in the future. So data analysts, but everything starts with data analyst. Data analysts collecting data, analyzing it, preparing clusters, and preparing the models for the data scientists for further actions. And also we have in our team full stack, one full stack. He's really wonderful. He can do everything, back and front end, website, developing services and databases for functionality. And our products and models on the base of big data. We will talk in details more about the big data, but we have currently a really successful project models. It's Geoanalytics. We will also discuss further scoring. And if you are interested about our scoring system, you can go to our stand and ask product owners and others more in detail. It's really wonderful system which helps financial sectors and others to assess and understanding the future behavior of our clients, abonnents. And we also have tourist and parent models. Do you know that by analyzing your data, we can understand who's your relatives, who's your friends, and we can understand to whom will be interesting talk, like our product might be interesting, and we can just creating your round of friends. And also we offer business analytics and dashboards. We analyze by analyzing our abundance or the data of our clients and making the helpful dashboards for making a decision for their stakeholders faster and more valuable. But main point is today of my topic is big data. Yeah, it's working. What actually big data, and how we can understand what is a big data? Is it any amount which was defined, or like say, do you know what is it actually big data? Do you have any understanding about the data, colleagues? Maybe you have any ideas?
Data and internet.
Yeah, actually it's unstructured data, but whatever. So it's really hard to define a term of big data, but I will try my best, and I will read from some sources. What makes big data big, and how does it differ from our traditional understanding of the data? The difference is not really in size. In other words, there is no clear demarcation. You can say that data which is larger than X amount size becomes big data. Although we have been storing and processing data for decades, the rate of data generation has accelerated substantially, particularly in recent years. And you know that 90% of the data which we have currently have was collected in the last 2 years. Did you know that? Yes, and the velocity of the collecting data is rising extremely. And this one was actually a fun fact which I found in Google. So Google never lies, I guess, or not, who knows? So as new technologies enabled us to create and manage the exponential growth, availability, and usage of the structured and unstructured data, we began to call it big data. But first definition, which was offered, I guess, by Gartner, was in 2001. It sounds like this one. Big data is a data that contains great variety, arriving in increasing volumes and with ever higher velocity. So we have already 3 components which, when you ever learned about the big data, you might face, I guess. It's a variety, volume, and velocity. But we have also 2 extra components, their value and veracity, I guess. Yeah, velocity and veracity. What do you think? Why these 5 components are crucial? Why volume, velocity, variety, and value and characteristics are important. Do you hear?
Because if you're collecting data very slow, in a slow way, it becomes useless. Basically, you cannot apply it anywhere.
It's a values, yeah.
And the volume, you're trying to grab more audience, like the bigger scope of audience, so that you can analyze it better.
Yes, correct. Volume actually refers to the big data. I mean, volume is extremely important part. So velocity, how fast you're collecting data. Variety is we have structured and unstructured data. Traditional methods of data usually use structure when you have already predefined characteristics, predefined places. For example, Excel files, it might be for the bigger companies, it might be relational databases. For the unstructured data, we can say that it's when you're just liking something in Instagram, it's also data, but this one is not particularly predefined. So it might be music, photos, or even emails or other types of the data. So it's unstructured. And how do you think big companies usually use which type of data? Structure or unstructured? That's correct, guys, because 90% of the data, again, 90% is today's leader, so it's unstructured data. But they are hardly managed, and unfortunately, yeah, it demands a lot of effort to work through this process. But we have also semi-structure, which is like a combination of the structure and unstructured data. Actually, big data is different from data that was used traditionally as objectives, plans, processes, and tools are very different. Let's now turn to the characteristics, the difference between data from traditional data. There are 5 key tools, like characteristics, their flexibility. A traditional database is based on a fixed schema that is static in nature. It could only work with the structured data that fit effortlessly into relational databases or tables. In reality, most data is how we define it, unstructured. Big data uses a dynamic schema that can include structure as well as unstructured data. The data is stored in raw form and schema is applied only when accessing it. So also, the second component is a real-time analysis. Traditional data, by nature, it uses data which already exists. It was distributed among several computers. It was already like took a place somewhere, event or period. But with big data, analytics takes place in real time. As the data is being gathered, the findings are presented practically instantaneously. This capability enables breakthrough in the medical safety, smart cities, manufacturing, and the transportation domains. Distributed architecture, while traditional data is based on centralized database, and they usually use one machine or several machines, big data uses several, and we can transfer into several machines, and we can add some extra places. So it's helpful for rising data, so we cannot think so hard about the way how we will manage in some period of time. Multitude of sources. Usually, traditional type of data sources are fairly limited, but big data can use the different types, and it's not limit for the sources using in a big data. Enables exploratory analysis. In traditional approach to the data analytics, users had to determine their questions at the start, but big data can agile and try to fix to the current time trends and be flexible in terms of the demand. So next, I guess, we discussed about the 5 pillars. Okay, 5 pillars. We also discussed sizable structured data, some programs. So next one. Data sources. How architecture is data sources. We can collect structured and unstructured data and go to the data ingestion, data processing through the most popular tools like PageSpark, and raw data storage in a Hive, and data visualization is through ClickSense or any other BI tools. So also big data, well, yeah, big data. Challenges might be different, like budget requirement, data center workflow, data quality assurance, performance of the data, the storage goals, mastery analytics. But what they are actually is when you want to implement big data team or big data resources, it demands a lot of high technical machines or computers, so you also need invest a lot of money to handle this big data and so on. So just it was really good presentation, but everything is just going out. Okay. What is a Geoanalytics? Geoanalytics is a term used to describe location-based data analysis. The main idea of Geoanalytics is presenting big data on the map or better representing of the data to the client. And also this one is Geoanalytics shows about the behaviors of our clients and so on. The main idea of Geoanalytics is applying geography to your business processes in order to gain analytical insights. Geoanalytics might be used in the combination of traditional analysis. You can on the map show how this density is high or less, or also you can use a different visualization system on one map. So how we use Geoanalytics in terms of Beeline? We are analyzing the behavior of our opponents, and we are seeing how they move from home. We have models like called homework model, which are tracking anonymously your data, collecting and seeing where like gathering of a lot of people, and also we seeing how they change like the data or not. And we are also working in case studies. We already working since 2019. We have the high data granularity. We have data for the 14 regions, which is very high, and we have the accuracy 500 meters and meter square. And we can also making analysis from big cities to the smallest one, telling a lot of things which might help to businesses identifying the competition analysis, where it will be how for if we are seeing the cafes, restaurants, they can also analyze and see where opening the shops or opening restaurants, cafe will be profitable for the companies. They can identify which status should be put. For example, close to the universities or other places, they can open, for example, like fast foods or something related. We can identify and telling our customers should they open in a particular place, will be it profitable or not, and also we can say around how many visitors they will have daily or so on. Constructions companies, they also can segment their clients and also segment what kind of building should be built and what kind of transport or other stuff located, so demand will be higher. Banks for also putting their ATM machines and identifying where the flow of people will be big or not, and so on. What kind of concerns might customers have? It's negative experiences when they already try to like using Geoanalytics, but the data were not accurate and they were not so straight, and they miscalculate the data and they could not use this data properly. Higher data error. Also by analyzing the data, they might make errors and so on. Data security, your data might be in the hands of others, so they can use it in the wrong ways. High price, some companies offer these Geoanalytics tools and they're extremely high, and it might be like over the budget. Superficial knowledge of the client. Sometimes you should know your clients, the nuances of the clients. If, for example, you know more in detail what he's planning, not just the basic information that it's bank and they want to open 1 billion and so on, but you don't know that they are going to open small branch, not the big one, and so on. You should also always know more about your clients. Fear of not solving your problem. When you are going to someone and asking about the Geoanalytics, you are expecting that your will be successful. This Geoanalytics will bring you profit and you can change it into the cash back. Sometimes it's not happen because higher components were wrong, it was not correct data or other aspects, so they can miss the chance. Criteria for Geoanalytics. Objective information, which I mentioned, the data should be real-time, objective emotion, and large data coverage. So you should also know not only for the particular small places, but also the bigger, and you should see the overall picture of the whole data, and data which you are using should be like active. Tracking by location and deep audience segmentation. When you can say this age, for example, I need to open the shop for the younger generation, you should also segment from 18 till 25 and also say that they can afford this stuff locally, having they use something, computer analysis and so on, ability to predict business performances and competitive costs. All these stuff are offered by we are offering to our clients, and I think it will be helpful. Data visualization. Data visualization is a representation of the data. So what we are doing is a big team might be just nothing if we cannot present to the clients and saying that present how it can be helpful. And we are presenting data by using charts, plots, infographics, or even animations. At the end, client sees only final results. He is not saying how hard work data engineer or how accurate was the data scientist models or other aspects of the data. He's saying with his eyes, and he says, I can use the filters, I can use some criteria, I can, this one is the data. For example, you can just say the quantity of data is this one, but you can also tell the story with the data, how it can be possible. You're just saying you're just saying you're highlighting the bigger spots, and you're saying why it happened. For example, we had the client which he sells say drop, but you don't say why it happens. Sometimes it might happen because of the for example, this street or this place was closed or something. This place like extremely cold weather might be also the reason. Or we had a client which sells drop because it was like his competitor also presented his new project, so it was more successful. What kind of steps we need for better visualizations? Define the clear purpose, why we are doing, what we want to tell with the data. To know your audience, to whom you are doing. For example, for stakeholders, you are doing completely different dashboards, KPIs. For the like managers who use the data every day basis, they need more tabular form of the data than just KPIs. They need more detailed information. And keep visualization simple. You don't need, and also it has great like flow. In one dashboard or in one graph, it should be only 5 graphs or something. And just visualization should simply, quickly give answers to your questions. Choose your right visual. You cannot like use histogram or bar chart for the trends. So you should understand which chart should be used for the particular case. Provide context. So you should say why it happens. Sometimes if you're like analyzing client segment, you should give more detailed analysis from region, age, their incomes, gender, and so on. And give access to your clients. So the main goals of visualization is explore, monitor, and explain. Explore, you should understand yourself what kind of data we have and so on, and monitor when users need to check their performance or focus on the particular parts, and explain. You should also say what is happening and why it's happening. So it's a types of geoanalytical visualization. We have 12 types of geoanalytics types. Each uses for different purposes, and if you have time, you can come to our stand, and also we can see, for example, for understanding how they move, you can also you can use this data space distribution or spider map or flow chart. We can easily say how he moved and how he moving the data. So, Shelly, thank you for your attention. Any questions? No? Thank you. I was really nervous, guys. Sorry, I forgot half of my presentation. You did? Thanks. Thank you.